Hey guys, it's Casey and I am here with a tower defense tutorial. I'm going to try and make this as beginner friendly as possible, so hopefully everyone and anyone can understand this and follow through. And I've done a little bit of planning on what I want to talk about, but I haven't really fully laid out this tutorial, so a lot of this is going to just be my normal workflow, my normal course of logic and thinking, and I'm going to try and slow it down and explain kind of every step of the way of why I do things. And I hope that that'll help you do more than just copy what I'm doing, but hopefully that'll help you understand what I'm doing. And if you are a beginner to blueprints, I really advise you watch the 3-part series that I did on the most important concepts for beginners to master in blueprints. And I really believe if you watch those videos, then this tutorial will be a breeze, and there probably won't be much that you don't understand. Those videos, I believe, are really critical to understand, to be able to work in Unreal and to really understand what you're watching when you do watch tutorials. So if you haven't watched those, I really advise you to maybe pause it here and go check them out and then come back, and I really think those videos will pay off dividends later for you. So what we're going to do first in this tower defense is that, or I guess let me back up. This is just, I just opened up a top-down template, and this has the starter content. I haven't touched anything really, so this is just a base project. If you want to follow along, it's just the top-down template with starter content enabled. So what we're going to do first is, if we open up our level blueprint, I've kind of jot down really quickly what I believe are kind of the first steps of making a tower defense. And the first thing that we want to do is that we want to make some AI runners, because that's really what a tower defense is, right? We spawn some AI, it runs a path, and that if it gets to the end of the path, we take away some of the lives from the player. When the player's lives hit 0, kaboom, the player loses. The second thing we need is we need towers. We need to be able to shoot at those runners while they're running along their path to try and stop them from getting to the end. And then the third thing that we really want to make is we want to make a UI so that we can dynamically create our towers where we want them to be and then select different towers. Now it's going to get a lot more complex than this. We're going to be doing things outside of these three bullet points, but I do believe these maybe are the very overall hierarchical kind of concepts that we're going to be doing first. So in the first video, let's handle the AI runners. So the first thing we want to do is let's go over here to our content and let's make a new folder and let's make it AI. And what I like to do is that I like to make some extra folders and not just clump everything in one spot, and that we can put most of our AI logic inside of this folder so that whenever we need to deal with our AI, we just need to open up this folder and we can find what we need. So what we want to do is, if we right click in this open space, or if we click add new, we get this menu to add new things to our game. What we want to add is we want to add a new blueprint, because what I know is that we need the runner. We need that physical actor that is going to be running through our level. So if we make a new blueprint, if we look under common classes, we have the first one is called actor. And an actor is simply something that could be placed or spawned in the world. This really is just anything that exists in your world is going to be an actor. Now you can see pawn under it is a type of actor, and it is simply something that can be possessed either by the player or AI. So we can get input from either a player or AI with a pawn. But then we have a character, which is a type of pawn, which is a type of actor, and the special thing about a character is that it has a movement component and some other things so that it has the ability to walk around. So with our AI runner, we know we want to spawn it, we know we want AI to control it, and we know we want it to run, so let's make a character. So let's call this our AI runner. And now if we open up our AI runner, it is just going to be blank, so we need to do a little extra work here to set it up. So let's click on our mesh up here in the top left. If you don't know this area, this is your components, and your components are basically the physical actors, sometimes scene components, collision. You can see if we do add components, there's a lot of stuff in here. It's basically anything, most of the time visual, sometimes it's invisible components like a movement component, but it's really the things that combine to make up what is this actor. So on our mesh, we want to actually set it from being none, and let's just select the one mesh that we have, and that is the SK mannequin. You're going to see it pops it up and it offsets it. Oh no, that's a little inconvenient for us, but what we can actually do is, if we minimize, if we look at the default character that we have in the level, which is our top-down character, if we select him, in the top right, we can do Edit Blueprint, and we can do Open Blueprint Editor, and now we're inside of that top-down character. In the top left, if we select the mesh, we can just copy these values, so we can see they offset the mannequin by 95 -Z. So let's just copy that over. Let's copy paste that in so that snaps them down. It's -90 in the rotation of z. So let's copy that rotation. And then the last thing that we want to do is see how he's just in like this A/T pose type of thing. It's because his animation blueprint is not set up. If we go over to our top-down character, I'll show you a little trick. If you hit this magnifying glass, we can see that the animation blueprint for the top-down character of the mesh is third person underscore AnimBP under C. If we hit this magnifying glass, it browses to the asset in the content browser. If I click it, you'll see nothing really happens. But if we minimize, you'll see that it browsed inside of our folders directly to that third person underscore anim blueprint, and it selected it for us. And then the really cool thing that we can do is that we can go back to our AI runner, and if we hit this arrow, it'll pop in that selected asset into this field. So that's a really easy way of kind of copy pasting some of these things that aren't really values, that are references to blueprints or whatever it might be. You can hit the magnifying glass and you can hit the arrow. You can see we even have it for like the skeletal mesh. You have it for materials. It's just a really quick and easy way of kind of copy pasting references. So that sets up the beginning of our runner. You can see now he's kind of bobbing and weaving. He's in the right location within the capsule. He looks pretty good there. So let's set up the next part of our AI. If we navigate to our AI folder, so what makes up our AI is it's going to be the actual character. So now we can drag in our AI, so we have our physical character. And now what we need is we need an AI controller to control that AI. So if we open up our blueprint, if we can do a new blueprint class, you can see we don't have an AI controller under the common classes. We have a player controller, but that's not an AI controller. So under all classes, yours might by default be popped up. If we pop that down, we can search, and we can search AI controller. And you can see here we get actor, controller, AI controller. You can read it if you'd like to. That gives you a little bit more information. But I just know whenever I make new AI, unless I know I have a controller in place that I want to use, I'm probably going to make a new one. So here, we'll call this our runner controller. And now what we want to do is we want to set up the last two pieces of information that we need for AI. And if we right click, instead of doing new blueprint class, if we go down under artificial intelligence, you'll see we have a behavior tree and a blackboard. These are used for running kind of extra logic, or actually running any type of logic really for the AI. So here, let's create a behavior tree, and we'll call this runner tree. And if we go back and we do artificial intelligence, create the blackboard, we will do blackboard or runner blackboard. Let's just keep it consistent. And then if we just do save all, you'll see me do this a lot, file save all. I do this constantly while I'm working. It's a really good habit to get into. And now if we open up our runner tree, Unreal is very generous to us, and it auto-populates this blackboard asset with our blackboard. If yours isn't selected already, make sure you just do that drop down and select it. And what that does is it hooks up the behavior tree and the blackboard together so that now they know each other exist and we can communicate between them. So there's one more thing we want to do, and if we open up our runner controller, we want to add just a small piece of logic here, and we want to tell the AI controller what blackboard are we using. So if we drag off the begin on begin play, because what event do we want to use here, I just want to tell the AI when it spawns what blackboard we want to be using and what behavior tree, what logic we really want to run with that AI. So if we drag off begin play, so this is going to be the first tick that AI exists, we're going to run this piece of logic, and if we type in blackboard, we can find under AI, we have use blackboard. We can punch that in, use the drop down, select our blackboard, and now what happens here is that when the AI starts, we select our blackboard and everything is almost hooked up. Let me take that back. There's one more thing we need to do to hook up this chain of logic, and if we go back to our AI runner, we need to go inside the class defaults, and inside the class defaults, you can see here that we have auto-possess AI when it exists in the world, and that our AI controller class is the default AI controller. However, we made a new one, and if we do the drop down, you can see we have a new runner controller. So if we run through this logic, when our AI is spawned, it's going to be auto-possessed by AI, and what AI controller is it going to use? It's going to use the runner controller, and then inside of our runner controller, on the first tick of it starting with the actor, we're telling it, hey, this is the blackboard that we want to use, the blackboard and the behavior tree that we want to use, so now everything is hooked up and good to go. So that's the basics of setting up an AI. So the last thing that we want to do is that we want to tell the AI where to run. So to tell the AI where to run, the first thing that we want to do is that we want to set up a nav mesh. So if we go into all classes, and inside this top left, we just want to search nav. And then you'll see we have a few different navs, but we want nav mesh bounds volume. A nav mesh is this mathematical calculation of the game deciding where the AI can actually run. So let's say that we want our AI to spawn in this back corner, and we want it to run, at least at the start, we'll have it run all the way to this corner. So let's take our nav mesh, and if you hit W, E, or R, it's a quick shortcut to go between translate, rotate, and scale. You can see here, you can do it up here if you want. I like to use the shortcuts, and let's just scale that in Y. And how we can actually visualize this is that in the world, if you hit the P key, you can see that, oh, boom, we have all this green space. Actually, I believe I might have made a mistake, and we actually have a previous nav mesh volume. Let's delete that. We just want the one that we have here. And now, with this nav mesh, you can see it's only green where we have our nav mesh. It's perfect. The other way of actually doing that, if I turn that off, if you go under Show, you can see there's navigation. You can see the shortcut is P. That's what I meant by pressing P. And if we can click it, you can see we can visualize our nav mesh. So let's just stretch that out. Let's get that to be a little nice and tug inside of there, and that should be good enough. So now, if we had our AI here, and we told it to run all the way over here, it would calculate on the nav mesh, and it would say, hey, I found a distance that I can run as the AI, because now we have this nav mesh set up. If you ever give your AI a location to run, and you can see that it's running inside the blackboard, and you're like, why isn't my AI moving? Very likely it might be an issue with your nav mesh, so I really recommend often if you ever have issues with your AI not running around, it's very likely probably something to do with your nav mesh. So very often, if you ever have issues, visualize it and make sure that it is calculating. So now what we want to do with our AI is we want to give it a little bit of logic. We want to tell it where to run. So inside of your behavior tree, this is your tree of logic. If you see here how you visualize it, it really is a tree. You usually go from one node to the next, and then you have some branching amounts of logic. For us, we don't really want any complex logic in our runners. For us, at least at the start, for a very basic tower defense, we just really want to tell it to move through a location. We have to use a composite or a type of logic selector before we can use a task. So here we just want to use a sequence that'll just execute in order of whatever logic we have placed under it, but we're really only going to give our AI one piece of logic. So if we hit new task up here on the top left, you'll see it creates us an entire new blueprint. You'll see it's called BT task. It's a blueprint task, and it's called base_new something something. Let's actually rename that. So if we minimize and we rename, let's call this BTT, and we'll call this runner move to. And now if we open it back up, you will see that this behaves a lot like an actor in that we get a blueprint with open space for logic and our event graph. So what we want to do is we want to use the begin execute. Let's see here. If we type in execute, you'll see we get two execute nodes. We get an event receive execute and event receive execute AI. Let's pull both of them up. And let's see what the difference is. You'll see here the main difference is the blue pins. With just a normal receive execute, we get an owner actor reference. However, if we use event receive execute AI, we get a controller, our AI controller, and our controlled pawn. That is what we want. We don't want to use this normal receive execute. We want to make sure we're using receive execute AI. So what I really am just going to do here is I'm just going to say right when this logic runs, right when our AI spawns up, we're running our behavior tree and we run this piece of logic, I really just want to tell the AI, move to a location that I'm going to give you. We're going to feed it kind of an end location at the end of our path. And whenever you're using AI and you're trying to give it some type of command, you want to drag off its controller pin. And with that controller pin, we can say move to, and you can see we get a few move to or a simple move to. Let's just do a simple move to location, and there we go. We have our move to location, but we need to give it a end vector. We need to give it a goal of where we want to move to. So let's set that up right now. So what I'm actually going to do is we're going to take a little bit of a step forward, and we're actually going to feed it a end location through our spawner. So what I really want to do is I want to create a new actor, and the reason being is that I know when later on, when we start spawning the AI to have them move through the level, I want to use a spawner or an actor that I'm going to call a spawner to deal with our spawning logic. I know there's going to be some additional complexity with spawning, in that I want to handle that logic somewhere in a confined space where it's separated from something from other logic. I don't want to put our spawning logic in like the level blueprint. I really want to put that inside of an actor. So let's make a new actor. It's going to be a blueprint class, and I want to do actor because we don't want to possess this spawner. We don't need to have this spawner move around. We just need this spawner to exist somewhere in the world, and that's what actors are for. So let's make an actor, and let's call it our spawner. So what the purpose of the spawner is, like I said, is as it's named, it's going to spawn our AI. And this might be a little bit of a logic hurdle for people, but you can use actors as just logic. This actor itself, the spawner, we will never give it any type of visual. We will never go into our viewport and start adding visualizations to it. We'll never really move this spawner in the world. This spawner just exists for the sole purpose of running code. And that is very common inside games, is that you use these empty or these invisible actors to help run game logic for your game. And that's really, really common. Not everything has to be visualized. Not everything has to be existent and moving around in your world. We can use a spawner for the sole purpose of just running some logic to spawn our AI. So what I know I'm going to do is that I want to spawn our AI wherever this spawner is located inside of the world. So let's move it to our end over here. So this, where we put the spawner, is where we want to spawn our AI. So let's go into our spawner, and let's just spawn one AI to start. We'll get into it more complex in the next video, but for this video, let's just spawn a single AI. So on event begin play, which is the first tick of our spawner existing, which, because we have our spawner dragged into the level, it's going to be the first tick of this level. Our spawner is going to spawn actor from class. Or actually, we don't want to spawn an actor from class, I apologize. We want to spawn AI from class. So if we do that, what we can do is that we can use our dropdown and we can select our AI runner. So the one thing that we don't want to do here is we don't want to feed in a behavior tree. If we wanted to, we could use the dropdown and select a behavior tree, but if you remember, if we open back up our AI controller, our runner controller, we're saying use a blackboard when the AI starts existing. What will happen is that if you use this code for event begin play, use blackboard, and where you spawn the AI, you tell it to use a behavior tree, it's going to end up duplicating your behavior tree for your AI, and you're going to have an AI running around with technically two behavior trees. That's not what we want. The reason why I do it that way is that if we ever need to, for debug purposes, just drag an AI runner into the level to see if things are working, if we're not using, since like say we deleted this code on event begin play to use the blackboard, and we dragged in our AI into the level, we're not telling it what blackboard to use because we wouldn't be using the spawning logic. If the only place we tell our AI what blackboard to use or what behavior tree to use is when we spawn it, that means that we wouldn't be able to drag our AI runner into the level and have it use a behavior tree. There's just a little bit of a gap there. So by telling it inside of the AI controller to use the blackboard, we then always know that whenever our AI exists, it will use that blackboard, and that we don't have to tell it here to use one. So that's just why I did that. If that's a little bit complex, I hope that's not too confusing. It's just that we can either tell it to use behavior tree here, or we can tell it to use it in the AI controller, and there's just some added benefits to doing it inside of the AI controller instead of when we spawn it. So what this wants is a location, and like I said, wherever we have our spawner, because this is where we're doing our spawning, is inside of our spawner, all we have to do is do get actor location, and now when we start our game, we should get an AI that spawns. We just ignore this for now. It's saying that, hey, we have an error inside of our behavior tree here. Are you sure you want to run this code? Let's just disconnect it and compile so that's not in our way, because we just want to check, is it spawning? And this is a little annoying, but if we go back, you can see, hey, it spawned our AI runner. So the spawner is working, we're spawning our AI, and if we wanted to, we could actually open up our runner tree, and if we drop down the debug, it's actually not finding any actors. I believe that's because we actually don't have any code here. I believe that's why that is. If we hooked up our task, our runner move to task, I believe now if we reran our game, so if we hit play again, we can hit eject to look around, we see we have our runner, and now, no, we do not. We are not running our behavior tree. So why is that? Let's see here. So our runner controller, we have that. We're saying use Blackboard. We're feeding it the Blackboard. Why are we not getting our AI? That is actually very peculiar. So let's actually look around. Did I use the wrong piece of code here? Let's take Blackboard again. I believe get Blackboard is what we want. Why are we not running our AI? Maybe it's also because there's nothing hooked up inside of here. Let's actually finish up our code. I believe there's a little bit of a hiccup between there's no code to run. I believe that's why it doesn't like that. We'll see that in a minute. Maybe we ran into an issue. This could be a good debugging experience. So let's kind of move forward and we'll come back to that and we'll see if there's maybe an issue I haven't thought about just yet. So what we're missing inside of our move to task is it doesn't like the fact that we don't have a goal. And like I said, we want to spawn our AI here and we want to move it all the way down to the end and give it a goal. So what is an easy way to do that? Well, what we could do is that we could just like drag something into the level. We could just say like, hey, what is something here? Let's grab some geometry, maybe a box. We could just drag whatever into the level and we could move it to where we want. We could copy paste that location and give it to our AI. But that means that whenever we want to make a new map or that whenever we want to change around where we want the AI to run, we need to feed that in a new location, and that's a little annoying. There's probably a better way to do that. And one way that we can do that is that if we go into our spawner, we can make a new variable. We can call this our end location. We can make it a vector because we want it to be a location. And then we're going to do something a little special here. What we want to do is we want to make this instance editable, and we want to do show 3D widget. And I'll show you what this does, is that those two options, what it actually gives us is that if we go to our spawner, it gives us, as you can see here, something called our end location. That's the name of the variable we made. And you can see we can drag off our end location independent of our spawner. It's a little like it's a sub kind of 3D location inside of the actor. So what we want to do is let's drag that all the way down, and we'll put this where we want our end location to be. So now, what we're going to do is we're going to feed our AI this end location so that when our AI spawns at our spawner, we're going to be like, hey, that's your end location, and it's going to go to it. So the cool thing about this is that when we finish up the spawner logic in our code, we can change this to be inside of any level. We could make 10 levels inside of our game, and all that we need to do to set up our spawner in new levels is that we drag in our spawner, we set the spawner to be where we want our AI to start, and then within our spawner, we just need to drag the end location to where we want our AI to end at, the end of our map, and then hey, it's set up. As long as you have the nav mesh set up, this piece of code, it's that easy to replicate it elsewhere. So now what we need to do is we need to communicate to this runner task the location from our spawner. So actually what we want to do is that if we go inside of our AI runner code, we're actually going to do a little bit of communication in between. So inside of our AI runner, let's open up the blueprint so that we get access to its code, and let's add a variable, and let's call this our spawner. And then what we want to do is we want to change the variable type to a spawner, that spawner actor that we made, so that we can do spawner object reference, and now our AI runner knows that we have a variable that we want to store inside of it, and that's going to be a spawner. And then what we can actually do is that inside of our spawner, we can take this return value, and that actually it's just a pawn object reference, so that what we actually need to do is I believe we need to cast this, because we can't just say, hey, spawner, nope. What we need to do is that when we spawn our AI, we get a return value, and if you watched the videos that I made on the 3 most important concepts to master in blueprints, you'll remember that this is just a vague object reference, and what we need to do is that we need to cast this to our AI runner. We're basically saying, hey, Unreal, this actor that we're making, since it's just a vague object reference, a pawn object reference, does it happen to be an AI runner? And since we know it's going to come back yes, we'll be like, hey, that is an AI runner. And then what we get back is we get back our AI runner object reference. And with that, we can then manipulate the variables inside of our runner. And what we can do is now we can say, hey, that variable that I just created over in the runner called spawner, inside of our spawner with that reference, we can say, hey, let's set that variable. We'll set it to ourself, because remember, we're inside the spawner here. And what our AI runner wants is it wants a reference to a spawner. We can use this node called self, and it really just gets a reference to self. And we're saying, hey, when we spawn AI, we're going to let every AI runner that we spawn know who our spawner is. We're going to give it a reference to our spawner. And the cool thing that we can do with that is now we can go back to our task over here, and that at the start of this AI running, we can take our controlled pawn, and remember, as we just did in the spawner, when we have a vague object reference, what we can do is we can cast that to what we want it to actually be, and we can say, hey, who the pawn that this AI is controlling, is that a runner? For our purposes, we know it's always going to be a runner, so what we can do is that we can then get off that reference to spawner, and now since we have the reference to our spawner, we can get out that end location. That's pretty cool, right? So now we can take our spawner, we make a variable called end location, we put the end location inside of the world where we want it to be, and that when we spawn our AI, we can say, hey, this is a reference to our spawner, and that in our code, we can be, hey AI runner, since I know that's the pawn that we're controlling from the AI, can I get the spawner out of you? And then from that spawner, we can then get that end location. If that was really confusing to you, then you probably didn't watch the videos I made on actor references, and I really recommend going back and watching those videos, the 3-part video that I did on understanding blueprints and really mastering them. So there's one more piece of logic that we need to do here. There's an issue if we merely just hooked up this end location. There's going to be a giant hole in our logic, and the reason why is that actually if we take this end location and if we put it back near our spawner, there's a little bit of extra gap in logic here. If we click on the location of our spawner, you'll see it has some huge values, right? Some negative 1500, negative almost 2000. But if you look at the location of our end location here, it's only 170. The reason being is that this end location is in local space, or it is relative to our spawner. So if we put it directly inside of our spawner, you'll see its location is 0, 0, 0, while the location of the world location of our spawner is some crazy values. So what we actually need to do is that we need to put our end location back to where it was, and really what our end location is 3,500 units positive Y from our spawner. So what we can actually do is that inside of our code, instead of just feeding it the end location, what we really need to do is we need to get the world location of our spawner, and we need to add that into the relative location of that end location. And what this will do is it turns that end location from being relative to our spawner. If we add it back into the spawner, it gives us the world location of that end location. And once again, if that was new to you, then you probably didn't watch part 3 of the 3 most important things for beginners to master in blueprints, which I keep talking about. Those videos are very, very important. I really can't harp enough how important it is to watch those videos if you have not. So now, what happens is that when our AI spawns, we hook up its blackboard, and then with that blackboard, we then run our code here. It's going to get to our root, it's going to hit a sequence, and a sequence just really runs our code, or runs this logic in order. Since we're only feeding it one piece of logic, we're really just saying, hey, run our run2 node, and inside of that run2 logic, we're saying at the event receive execute, this is going to be the first tick of this AI running. It's going to be, hey, is our controlled pawn a runner? Yes, it is a runner, so let's get off our reference. Let's get a reference to that spawner that we set as a variable, and let's get some of that data that we stored, and now we have our move to location. So if we hit play, hopefully, our AI does not move. Oh no. Okay, so I do believe we have an issue with our blackboard. So if we do this drop down, it's saying can't find matching actors. So what I'm going to do is I'm going to reverse some of the logic that I did before that I talked about. Let's unhook this event begin play and use blackboard, and let's actually go inside of our spawner, and let's actually tell it to use that blackboard. Let's see if that fixes it. There might be an issue there. If we hit, yep. So I think I'm missing something. I think I'm using the wrong node. I'm going to actually double check that in the next video when I get some time. But there appears to be some type of hole in my logic here inside of the AI controller. I thought it was use blackboard. Is it behavior tree? Is that what the actual issue? If we type in behavior, that's probably it. I was using the wrong node. So now let's actually replace this use Blackboard. Let's go inside of our spawner. Let's actually set that reference back to none on the behavior tree. That was the issue. Okay, a little debugging for you. I was using the wrong node inside of our runner controller. So now if we reverse it, so now instead of giving it the behavior tree when you spawn it, let's run that inside of the controller. So now when we hit play and we hit eject, we can see, hey, our runner is running from the location that we spawned it all the way to that end location that we just fed it. So that will make up part 1 of the video. Very simply, we just set up our runner and we just told them to move to that end location. If we wanted to get a little bit more tricky, let's actually do one more thing. Let's add another nav mesh to our level. So let's go under all classes, let's type in nav, and let's use another nav mesh bounds volume. Let's drag it into our world, and let's stretch this out onto this side too. So let's make that a little smaller. So now it's a little smaller. There we go. So something weird happens. I'm not entirely sure the reasoning why. When you're using multiple nav meshes, the first nav mesh that you place, for some reason, you can see there, it was invisible. We had to like just barely wiggle it, and then you see it pops back up. So now what let's actually do with our spawner, let's move that end location and let's move it over to this corner. So really what I just did is I just added another nav mesh to another side of this wall, and with that extra nav mesh you can see we get an extra green path, and then all I did was I dragged that end location to that new location. So now if we hit play and we hit eject, you can see our runner is going to run along our nav mesh, it's going to turn at that corner, and it's going to run to our new end location. So that really is as simple as it is to hook up our locations now. By instead of merely going inside of our task, and instead of using this code, instead of doing this and just doing like make vector, finding in the world where we want that end location to be and manually typing it in, instead with our spawner we can use the whole end location idea that we used, and we can dynamically just quickly move around this end location, and our AI will automatically update with it. So that handles part 1. In part 2, we are going to set up towers, and we're going to make some towers, and we're going to set them up along this path, and they're going to shoot at our runners while they run, and that will be part 2, and I hope you guys learned something. If you have any questions, or if you even have some constructive criticism, this is the first real full-length tutorial I've done on YouTube, so if there's anything that you think I can do better, please let me know, and I'll be sure to listen to the criticism, or if you have any questions, please let me know, and I will answer them, and I will see you guys in the next video.